Hello and welcome to another riveting episode of I Fix Old Stuff. Today we're looking at the 5 things you need to know about power supplies. Let's go. Before we get started, let's take a look at this diagram here because I believe it's going to set us up for success for the rest of the video. This diagram shows the 3 properties of electricity we'll be discussing today. The first one is voltage. As we can see by the diagram, voltage is a pressure. Resistance, obviously, is resisting or controlling the flow of electrons. Current, then, is the amount of electrons traveling through a circuit at a specific time. Another analogy we can use is think of a power supply as a water tower. Voltage would be the pressure on the water to flow to your house. In the case of a water tower, it's gravity. Resistance, then, is your water tap, allowing you to control the flow of water into your home. Therefore, current will be the amount of water flowing through a tap or pipe at a specific time. If you keep that in mind, I think this video will make a lot more sense. Now that we know this, let's take a look at the 5 things you need to know when replacing or perhaps repurposing a power supply for your own project. First thing we need to know about power supplies is the rated voltage. All power supplies will have a specified input and output voltage. The power supplies you see here are all DC power supplies, which means they're taking AC voltage in from the wall and converting it to DC output. For example, this power supply here from an old laptop is rated at 16 volts on its output. This one from an IP phone is rated at 48 volts. Most guitar effects pedals you will see use 9 volts. Chargers for cell phones that use a USB cable are always 5 volts. You will occasionally see these power supplies that output AC voltages. This means that the conversion, or what we call rectification, of DC voltage is occurring inside the connected device. The key thing to remember here is that the voltage on the power supply must match the rated voltage on the device you're connecting. This is usually found on a sticker on the device or perhaps engraved or molded in some way. If not, check the instruction manual or spec sheet. The current rating of a power supply is the amount of amperage the power supply can supply. Think back to our water tower analogy for a second. The water system that we have means that we can take only the water we need at a specified time. Otherwise, there'd be a lot of ruined glasses of scotch. It's the same with electronic devices. They take the amount of current they need from the power supply. Therefore, the current rating of our power supply must be able to meet the demands of the device. Most oftentimes we use power supplies that have more current than we need, for safety or for devices that may have current demands that fluctuate. So, if you're choosing a power supply, keep this in mind. The current rating does not need to match, will usually be higher, and the device takes what it needs. Again, think of the water tower. The system wouldn't be very good if every morning when people are showering it can't keep up to the demand. The current needs of a device are usually labeled. However, if you're doing prototyping or DIY projects, you'll probably need to calculate that or measure it for safety. Power supplies come with a wide range of connectors. Earlier ones had this style of connector called a 1/8 inch plug. For example, this old Mattel handheld game from the late 70s or early 80s. The most common connector is the barrel connector. These are rated by the inside and the outside diameters of the plug. For example, most guitar effects pedals use a connector that's 2.1 millimeters inside and 5.5 millimeters outside. Many AC power supplies have a 2.5 millimeter by 5.5 millimeter plug, and that's probably to prevent plugging in the wrong power supply to the wrong device. DC power supplies will have the polarity of their connector labeled on them. What do we mean by polarity? Well, it's which part of the connector is plus, or positive, and which part of the connector is minus, or negative. Think about a battery, same thing. 1/8 inch connectors usually have the tip as the positive and the sleeve as the ground. Guitar pedals that use 9 volts, the tip or inside connection of the barrel is negative, and the outside is positive, and we call that tip negative. This 12 volt supply, however, is the opposite. It is tip positive. The polarity of the connector must match the device you are plugging into. If you're not sure of the polarity of a supply, you can always check this with a multimeter. It's very easy. If the voltage reads positive, that means you've got the red and black leads hooked up correctly. If the voltage reads negative, then you've got the leads reversed. Earlier power supplies you will see are called unregulated. With nothing connected to them, they actually put out more voltage than they're rated for. However, they come down to the rated voltage when connected to a load or device, providing resistance. This is fine for older devices, but usually you will see what's called a regulated supply, where a device called a voltage regulator is added to the circuit, and that provides a steady voltage, for example 5 volts or 12 volts, up to a specified current. After that limit, however, the regulator will overheat and shut down or perhaps die. This design is not very efficient, but it works well and has worked well for a long time. Most supplies you see today are actually switching power supplies. They are light, efficient, and they put out a very clean, stable voltage, and that's what computer devices need. While you can fix earlier types of power supplies pretty easily, these newer power supplies tend not to be user serviceable beyond maybe a simple mechanical repair. You need specialized equipment and the right training. Therefore, when these supplies die, they're usually just discarded. So there you go. 5 things you need to know about replacing or repurposing power supplies for your own projects. Thanks for watching, and we'll see you on the next one.